Welcome to the periodic shelf of elements. This one has power. We've got some beautiful lights inside there. We've got neon and argon here. We've got helium up here, helium discharge lamp. We have the box of the rare earth series here, from lanthanum, cerium, etc., all the way down to ytterbium and lutetium. We've got some kind of fake radioactive boxes here. I like that old radioactive logo, but this is a polonium brush that was used for record players. It was made in 1968. Polonium has a half-life of 140 days. There's no polonium left on that brush. These are a bunch of quote-unquote radium watch dials that I bought on eBay, and I don't think there's any radium on those either. I tried to test them and they weren't clicking. This is a thorium, just a welding rod, a real skinny piece of tungsten that's maybe 2% thorium. This americium was a small bit that was taken from a smoke detector. That stuff, it doesn't go more than 6 inches in air, the radioactivity, and those three are just completely empty. They are lead cans to shield from radiation. There is no hydrogen here, but I've got lithium, beryllium, magnesium, and scandium, yttrium, and some barium down on the bottom here for the start of the series is here. So this is scandium all the way through. I've got selenium on the end. Of course, there's titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic. I've got aluminum, silicon, matches for phosphorus. There's sulfur, boron, carbon, and a block of Teflon for fluorine. Okay, down here, yttrium, zirconium, niobium, molybdenum, ruthenium. I don't have technetium. Rhodium, palladium, silver, cadmium, indium, tin, antimony, and iodine. And if you look real carefully, you could see that iodine logo there, the piece of paper, is just a little bit brown-yellow compared to the other ones. And as you move away, these ones that are a little yellow here start to get white. So a tiny bit of that iodine has been leaking out and staining that white paper brown, but that's all right. So barium, hafnium, tantalum, tungsten, rhenium, iridium, osmium, platinum, gold. I've got a mercury tilt switch from an old thermostat. And here's lead, my favorite, bismuth. Love bismuth. I made these bismuth crystals by melting pure bismuth in a steel pot and pouring it out just as the top of it starts to crystallize. Almost forgot about the ultraviolet box in the middle here. Turn that light off. So we have in here green uranium glass that is glowing, and there's some deposits on this rock that are glowing green under the ultraviolet. There's a ultraviolet lamp under there. It's a little hard to see with the main lights on. There it is. And we also have a vacuum tube back there which has a number 8 on it, and that is done in phosphorescent material, so that glows green also under the ultraviolet light. I've got some carbon allotropes. This is plain carbon, just activated carbon. This is Buckminsterfullerene C60, and this is a little piece of high quality graphene, single atoms thick, on a copper backing that a friend made for me. How about those bismuth crystals? They are pretty crazy looking, huh? Very beautiful stuff. Bismuth is a little bit famous because it's used in Pepto-Bismol as bismuth subsalicate. And so you can actually eat bismuth. I wouldn't eat the metal. Maybe if I was really hungry. This is a tungsten coil used in a Helix traveling wave tube amplifier. This is a second from a factory, and apparently some kids were playing with it and it got a little bent here, but that's okay. It's incredibly heavy for the small amount of metal that represents. Two of my favorites here that I like to show people This is a magnesium rod. Magnesium is the lightest or least dense element that you can handle without burning your hands. And I wanted to cut this the same size as this one. This monster is a block, I think, of elkinite, which is actually a tungsten copper mix. And I haven't tried to calculate the density or the constituents of it, the ratio of copper to tungsten, but I think it's about 75% tungsten. It is incredibly heavy compared to this thing, which it feels like a helium balloon could lift this thing off after you pick this one up. And so I love to show that to people. If they were the same size and if this was 100% tungsten, it would be 10 times heavier than the magnesium roughly. So that's a fun demo piece there. And then what do we have here? This is my sodium metal, which it's hard to see in there, but there are some chunks inside of a glass vessel in there stored in mineral oil, and it's stored about 10 years ago in there. It's inside a plastic bag which is filled with argon. The whole thing is filled with desiccant and argon and then taped shut, and it's not showing any additional signs of oxidation or anything. It still looks really nice in there. So that's my sodium. This is a little jug of about 3 ounces of uranium powder, depleted uranium powder, that is used for making pottery. Really nice orange-yellow finish for pottery is made using uranium powder like this. This is one of my favorites to try to puzzle people with. This is a 3-liter soda bottle. How on earth did it end up looking like this? Not many people can figure it out. Well, what I tried to do here was store helium inside of a plastic bottle. 99.99% helium. I filled it up and tightened the cap as tight as I could. Months or maybe years later, I opened the box to move the bottles, and I found this one completely crumpled up, and I was utterly puzzled as to what happened. Well, it turns out helium can leak right through the pores of this plastic, but no other gas can get in. So the entire air pressure of the world is crushing this thing into this shape, while there's pretty much nothing at all inside of it. Maybe a couple atoms of gas or a couple molecules of gas in there, but not much else. It's pretty much a vacuum inside of this bottle. Pretty cool, huh? This is another kind of fun one. This is gallium metal, which was probably mixed with indium and tin to make a liquid metal called, well, trademarked as Gallinstan. But it is pretty much retains its liquid properties down to about minus 40 degrees Fahrenheit. And it is quite dense. I think it's somewhere around 6 times more dense than water. So as you slosh it around, you can really feel some weight in there. Not as dense as mercury, which is 13 times heavier than water for the same volume. But it's a pretty fun little mixture you can make if you have the right ratio. It's about 68.5% by weight gallium, 21.5% indium, and 10% tin. That's a pretty. And you just put the constituents together. This is a block of indium, and here's the tin. And if you mix that with the appropriate amount of gallium, and you melt it down, it'll of course melt into a metal pool like this. But then as it cools, it will stay a metal liquid like this. And you might think it would be useful for a lot of stuff, but the problem is that it wets a lot of things. And so if you try to store it in glass, it will wet the glass. Here's a glass jar that was used to make this alloy, and it's still coated with metal inside. Somehow it doesn't coat the HDPE, which is good, except it did coat the top of this lid really well, which must be a different material. It's probably nylon. So it is very selective in what it sticks to, but it does stick to a lot of things. And it's not toxic. This shelf is actually made with a bunch of Christmas lights that I thumbtacked into this top of each shelf. There's a cutout in the shelf tops there for those lights to recess into. So it was pretty simple to put together, actually. I did wire in the ultraviolet light in here, and this guy up here has a high voltage inverter in the back, and that's connected down to a switch here, which turns on and off. Each time you press it, it toggles on or off. And so that is pretty much how the shelf works. The main power switch down here turns on both the Christmas lights, the argon, and the neon bulbs.